say, formal presentation of today is by Giovanni Maruzzelli. Giovanni is another very popular figure in the RTC community. I've seen him speak at pretty much all events I've been to. So he's very active in several projects, Camailio, OpenSIPS, FreeSWITCH in particular. And so he will be talking, and he's a consultant in that space. So he's the guy to talk to whenever you need help. And today we'll be talking about how to actually involve WebRTC and SIP together using FreeSWITCH and OpenSIPS. Thanks, Giovanni.
So I'm very happy to be here. I don't know if you saw my post on Facebook, but it was about a phrase from Goethe, the German poet, that is saying something like, you can't be really sad if you know in the future, sooner or later, you will come back to Naples. So actually, I was struck to how beautiful is this city. I'm proposing to myself and wife to come back and have some short vacation here. And apart from that, also the conference was very satisfying, beautiful, and to be the first time the organization was more than perfect. So please, big round of applause for Lorenzo and for Celeste. So this slide and this slide are about books that I wrote in the past, and I want to take this opportunity to commit and to announce that I began to write a new book. It will be about scalability, high availability in our in our industry, and so I will be in contact with your guys to ask about your experiences, your use case, what kind of solution you got, and so we can distill best practices in our industry and made available to everyone. So the agenda will be about how to scale and high availability in a conferencing system based on SIP, and we'll see each building block one if thought after other, just very fast, because I know that we all are almost on the plane. And we want a complete system, we want it scalable, we want it running 24/7, and we want something that we understand that is maintainable and something that we can depend on. So SIP has got video calls since the beginning, I think, because SIP was not invented to manage voice calls, but was invented just to manage the concept of sessions. Sessions actually can be of whatever, and in the context of a call, a video call is just a second stream that is attached to the same session. By the way, there was also a lot of different usage possible on top of SIP. Someone else also built some payment systems and whatever. So we have SIP that is used to carry multimedia, so both audio, video, and possibly other streams. But we need a lot of things on top to have a functional conferencing systems. You need channels for control, you need some chatting, you need the ability maybe to put some caption on the bottom of the video streams, and you need the ability to manage the participants. So to give the microphone to one, to the other, to mute someone that has a lot of background noise, etc., or kick out or whatever. Invite someone. And so there is much more than just a point-to-point voice and video call. Enter FreeSWITCH. FreeSWITCH has a lot of programmability and is, let's say, one of the top of the industry in terms of capability of switching between different, let's say, media. It can be SIP, it can be TDM, it can be WebRTC, etc. And you got, since the beginning, high definition audio that particularly for conferencing, it can be very important to be able to convey high definition audio CD-ROM, CD quality. And you can build very complex systems on top of FreeSWITCH thanks to Lua programming language that is very straightforward but a very real programming language. So it's not that you are limited by dial plan or dial plan logic. You usually you program in Lua, you have a real programming language with all your libraries, etc. And you have a lot of different tools in FreeSWITCH, from text-to-speech, automatic speech recognition, call center, queues management, T38, fax, CDR, you have it all. And now let's see what's WebRTC. WebRTC basically is a way to exchange from one point to another streams of real-time data and data channels for control. It has no mandatory kind of protocol for session or for user location. So to have the ring or to know where to ring, you must implement some kind of protocol that is not part of the WebRTC definition. So you have then the choice. You can invent your own protocol, or you can use one of the many protocols that has been adapted to work with WebRTC, particularly, for example, XMPP, or in our case, I will talk about SIP. And FreeSWITCH has also Verto protocol that is a special kind of and a special FreeSWITCH thing that that I don't use, but is there and is very good. And the important things with WebRTC is that it will be, and is alright, almost be the backbone for the media exchange in the Internet of Things. So it is, and so much more, it will be very, very, very scalable. We're talking about today some billion of web browsers. In the future, I don't know, probably billions of sensors and endpoints. And so we need to combine all these kind of avenues and all these kind of features and capabilities, and provide for the reliability that we expect from any kind of service, from security to AAA, authorization, accounting, and the other A that I don't remember. Okay, authorization, thank you. And to interconnect between all the different platforms that our client, our endpoints can be reachable. So we will see how to use in this framework OpenSIPS to OpenSIPS to do the security AAA load balancing dispatching. We will use SIP simple, that is a standard part of SIP, well defined, to exchange back and forth control command with the conferencing platform, for example, who has the microphone, who is in the video, etc. And we will use FreeSWITCH as a back-to-back user agent to accept the calls and to mix as an MCU the video streams. We will use the chat plan feature of FreeSWITCH to manage the incoming simple IM messages to give commands to the conference platform, and we'll use SIP.js as signaling library for the WebRTC part, so for the web browsers. And we will have some more pieces that round up our plat, and will be Cordova and Google push system. So we will then realize a smart app for smartphones that will wake up and or will execute itself the HTML and the JavaScript, or, and in most cases better, it will just launch the browser with the appropriate arguments. So it will not consume any kind of memory or battery, but will be ready when you need it. And this is the general schema of the platform, and these our usual things that we know how to do since I mean 20 and more years of SIP implementation of scalability. So we have any kind of clients of endpoints there that will speak with any kind of protocol to our entry point, to our gateways. So we will speak UDP, TCP, TLS, WebRTC, DTLS, pure SIP, or it will be browsers in the web. Then we have high availability, let's call it a gateway or proxy or balancer in front, that is made basically from three pieces that are OpenSIPS, or can be Camaleo, that is HAProxy and can be also Nginx, and RTPEngine, or can be RTPEproxy in front, and these are kept one or the other, so in an active passive way, by keep alive that will move a virtual IP. Very standard, very conservative architecture that works kind of well. Then it will be distributed, the signaling, on the farm on the back end, that each server in the farm is running FreeSWITCH, the web server that can be Apache or Nginx, and nothing else. And this is then baked by a cluster file systems and a cluster of database in the back. Let's say HAProxy. So that will be on the two proxy in the front, and we will do SSL termination for HTTPS and WSS. So it will be responsible for all that has to do with certificates, and that will kind of easy the management part for certifications. And then you will have on OpenSIPS, we will see in a while, plain WebSocket, so not secure WebSocket, but plain WebSocket, so you don't have to manage certificates in two places. And then in OpenSIPS, you have already, again, active passive with Keep Alive, and a pretty standard WebRTC that just manage plain WebSocket. And OpenSIPS is responsible for NAT management, RTPEngine or RTPEproxy controller command, registration, keeping user location, and dispatching of the sessions to the backend. So in terms of SIP, OpenSIPS will manage fundamentally register, invite, and message. Publish, subscribe, and notify in this case are not used. RTPEngine will take care of all eyes, so you need eyes for WebRTC, and RTPEngine will accept eyes from browsers and will, let's say, smartly delete eyes when it sends the session to the browser in the back. RTP routing is other things made by RTPEngine, so it will decrypt and translate all forms of secure media like DTLS, TLS, SRTP, and this feedback format of the SDP, and it will translate it all into the basic, simple RTP AVP on UDP. And it will also transcode, if you so desire, Opus to G711 to G729, so you can accept from the network those various formats. Particularly, you not so often find a single piece of software that can accept and send both Opus and G729. So in this way, it's very simplified our job. And then the FreeSWITCH farm in the back will see all and every time the same kind of session and media. So a plain session and media. And the FreeSWITCH will already get UDP, normal UDP session signaling from OpenSIPS. And another requirement is you need to have the participants in a conference or in another kind of maxed environment to be on the same machines on the back. So that's very easy made by OpenSIPS or another proxy that based on the unicity of the identifier that is called, for example, the single conference identifier, will send all the participants in the same backend box. This, again, I will show the slide now and then with the architecture so we can continue to follow. And the single FreeSWITCH machines on the back use OpenSIPS as outbound SIP proxy. That's a configuration keyword. So automatically they will send any kind of output toward OpenSIPS and blindly accepts registration and calls without asking for authorization from OpenSIPS, because that will be OpenSIPS that take care about authentication and verification. And on FreeSWITCH you have 3 different kind of mode to do conferences. You can have pass-through, and the pass-through is the most genial in my opinion. You can have transcode and you can have MUX. When you are in MUX, you are able to do very nice computer graphic on the participant video streams. And with this power, it comes a lot of CPU consumption. So it's just incredible what you can do, but you need a hyper powerful machine to do computer graphics live on many video streams in parallel. On the complete opposite of this, you have pass-through mode. Pass-through mode consumes 0 CPU. And this is so great that it's just incredible. So you can have pass-through mode with any kind of number of participants, and actually FreeSWITCH will just route the streams and will consume 0 CPU. And you can have so a person that is speaking and I'm on the video. Then I will begin to show my presentation with slides, and there will be the video of the slides and my voice that is talking on it. And just you go back and forth from the video of my face to the video of the slides. And this will be complete at 0 CPU usage. Then you have a transcode that is, let's say, the big brother, the older brother of pass-through, because it's a pass-through mode, but it's able also to convert from one encoder to the other. So it's more CPU hungry, but not so much, because transcoding is kind of heavy, but computer graphics in real time is very, very, very heavy. I mean, when you do real computer graphics on the video, you are kind of doing a Hollywood level CPU load, like Industrial Light and Magic. And then you have all the kind of command profiles. So for each kind of conference, you can map which commands do what. So if you press 0, you mute yourself. If you press 4, you lower your volume and things like that. The chat plan in FreeSWITCH is, let's say, the same kind of concept like the dial plan, but that elaborates, that process incoming and outgoing text entities. It is managed by mod SMS, also if it has nothing to do with SMS. It's just a misnamed module, because mod SMS has nothing to do with SMS, and actually is a generic text processing module that in the case of SIP simple is, let's say, is piggyback on mod Sofia. And so you can use this chat plan to deal with any kind of instant messaging. And in our case, we use it to elaborate and process command and control on the conferencing system. And particularly the interesting thing is that the conferences in FreeSWITCH has a special interface, a feature, so that you send a text message, an internal text message on a conference, and the conference will broadcast this text to all the participants. So this also is used by the application to have to build a chat system that will be shared by all the participants on the specific conference. Then we have our endpoints, and we can reach these conferencing systems from any kind of endpoints. And one of the important things now is to be able to cover also mobile systems, and mobile systems are usually defined by the browser or by an app. The browser usually is much much recent and packs much more features than what you have in a plain app. And so you have a choice, and we do both in specific cases. From one side, you can build an app exactly from the same code that you use when a browser connects to the conference, and so you reuse exactly the same code, and you embed in an app thanks to Cordova. Or you can use Cordova just as a launcher. So Cordova will get a push message from the server, and will start the browser with the appropriate arguments, so the browser will connect back to the conferencing systems and initiate the calls. This is very useful in this case because this is not like a phone, but it's something that, for example, you have your participants are registered to be in the conference maybe next week at 9 o'clock in the morning. So next week at 9 o'clock in the morning, the server will send a push, and they will be alerted. They will click on the alert, and they will be in the conference, or they just will dismiss. So in a way, we have all these kind of endpoints, and we have a way to let all these endpoints to interact with the back end. And you must think that you have two different kind of participants. You can be a simple attendee, or you can be the moderator. The moderator can give you the microphone, can shut you up, can kick you out, can decide who is on the main video streams, etc., or can change the format of the video, how the video is laid out. And as an attendee, you can just mute and unmute yourself or change the volumes. So there are many ways to do this. The most basic and the most usual is to use the telephone keyboard. So 0 to mute, 0 again to unmute, and such kind of commands. Or into a browser or into an app, you can have press buttons, move slides, and things like that to achieve the same kind of functionalities. So more or less, I try to keep this very short so we have some time to for question and answer, and also because I was thinking that almost all people will be kind of nervous because there are flights that wait for them. So please, I finished.
Thanks, Giovanni. Do we have any? Oh, okay, already.
Oh, Giovanni.
I'm against security.
First, I just want to establish the fact that ABBA doesn't suck. But apart from that, I need to take you back to my trainings and retrain you. SIP message is not part of the simple package at all. SIP message is an RFC that didn't come from a simple working group. So you need to update here and say SIP message instead of SIP simple, because you haven't got simple in mod SMS.
I will do that.
Ask Adrian about simple and you will go crazy very fast when he describes all the tricks in SIP simple. You won't get the microphone, Adrian. I have a number of questions. One is, how do you in FreeSWITCH handle the licensing that is required in order to encode the code H.264? You can't do that without a patent license from the Alliance.
I have no idea at all.
No. So everyone has to be a bit careful before using your MCU in commercial environments, because we do need those licenses still.
Yeah, but I have no idea how the people of SignalWire FreeSWITCH take care about that. I think that the most used encoder decoder for video is VP8 that is unencumbered. I know that now there is in FreeSWITCH two ways to interact with H.264, and one is a proper mod H26X that was written by FreeSWITCH people, that is just a pass-through module, so it has no encoding decoding.
No.
Then there is also recently a module called mod_AV that for sure is able to encode and decode. So your question for sure apply to mod_AV, and is probably using a library to do that, and I'm totally unaware about licensing and stuff.
I would say the only way to circumvent the license is not to circumvent it, but download the libraries, the binaries from Cisco, which gives you the Cisco license for 264. But I guess you need to look into that. You're claiming that WebRTC is the primary IoT choice. What's behind that? What's your reasoning?
What?
You're claiming that on one picture that WebRTC is the primary protocol for IoT.
The candidate, yeah, in the future.
Why is that?
But for what I got from as an impression is They made WebRTC, they scaled it to support a big number of browsers, and they're trying to push it as the media channel for IoTs. And with that kind of baking that they have, I expect, and it seems to me credible, that it can be a candidate for the IoT exchange of media. Then I have actually no idea, and the IoT is not here, so. Adrian, on simple.
I'm shocked to see the fact that you don't know what SIP simple is. Okay, so as Ole mentioned, out of SIP simple working group came several standards, one of them being the way to do chat, which is by a protocol called MSRP, Message Session Relay Protocol, which is another media plane like RTP. Second observation is that with the advance of quantum computing, we'll finally have negative CPU usage.
Cool.
Finally! Like interest rate.
So are there more questions for Giovanni? No. He asked if your website is secure. Joke on before. Then I guess we can thank you, Giovanni. Thank you.
Thank you to you all.